morning, geometry. I'm so sorry I'm not here today. It's an unexpected absence. Everything is okay, but I miss you, and I didn't want you to miss my voice. So here I am. This is page 17 in your notebook. We're going to page 17 and 18, and then 19 and 20 will, in fact, be your classwork and homework for Monday. So make sure you're taking these notes and listening carefully. On page 17 for exercise 1, a ladder will be unstable if the angle makes the ground if the angle it makes with the ground is greater than 60 degrees. If a 12-foot ladder is used to reach a window 10 feet above the ground, will it be unstable and justify your answer? So we need to make sure that we are recognizing the fact that we're talking about the angle with the ground. So that's right there. When you go ahead and you label these sides, we have the opposite and we have the hypotenuse. So the purpose of today is to apply what we know with the three comparisons that we are learning. Please make sure that you put these into your head because these are not given to you. In this case, we're comparing the opposite and the hypotenuse, which is the sine. We don't know the angle measure, so I'm going to call it G for the ground angle. You can call it whatever you want. But we do know, in fact, that the comparison of the opposite to hypotenuse is 10 over 12. Please remember that this, when we have a variable next to the word, means that in our calculator we use the inverse function and we use a fraction or the division symbol. When you go in your calculator, please make sure your calculator is in the correct mode by pressing the sign of 30 and making sure that it's 0.5. So the sign of any 30-degree angle, the comparison of the opposite to the hypotenuse is 1/2. So in this case, we're looking for the angle, so we need to use the inverse. And we know that the opposite side is 10 and the hypotenuse is 12. When you divide that, you get 56.4427. So 56.4427 is that angle measured. And the question says an angle that is greater than 60 degrees, it will be unstable. So this ladder will be stable. This ladder is stable since the angle is less than 60. Please make sure that you are pausing if needed to make sure everybody's getting these notes. The second example is very similar, except this time you're looking at an angle that's from an eyesight level, but you're still focusing on an angle and you're still focusing on a right triangle. In this case, this base, and this happens to be the adjacent, says to determine the height of a tree. To determine the height of a tree, loggers will measure the angle of elevation to the top of the tree from a set distance from its base. The logger's eyes are 5 feet 3 inches above the ground, and the angle of elevation to the top of the tree is 38 degrees when standing 25 feet from the base of the tree. So the picture already describes this. It says determine the height of the tree to the nearest inch. Please remember that we have this extra 5 feet 3 inches, so keep that in mind. This is 25 feet, so we're looking for the height. If you notice, this is the opposite. This is the adjacent, which we had already mentioned. So the comparison is opposite over adjacent. The word that goes with that is tan. The angle measure that goes with the word, we know this time. The opposite, I called H. You can call it whatever you want. The adjacent is 25. In this particular case, since we know the angle measure, we cross multiply. Again, I start with the variable, so 1 times H is H. And in our calculator, we plug in 25 times the tangent of 38. When you plug in 25 times the tangent of 38, 25 times the tangent of 38, you get 19.5321. Notice I'm not rounding very quickly. I want to make sure that we have the correct answer. So we have 19.5321 feet. But please remember that when you have 19.5321 feet, we have to add the 5 feet and 3 inches. Don't forget to add that. So when you add 5 feet, 3 inches, first of all, 3 inches is really 3 out of 12, which is really 1/4, which is really 0.25. So we can add this plus 5.25. Again, please make sure you don't round. Go up, copy that, and add 5.25, and you end up with 24.7821. 24.7821. And it says round to the nearest inch. So we have 24.7821 times 12 because it says to the nearest inch. Again, please don't round. So take that answer. Oops, my bad. So sorry. That answer and times it by 12 because there's 12 inches per foot. So it's 297.4. 297.4 inches, and it says to the nearest inch, so 297 inches. Exercise 3 talks about an isosceles triangle. Again, you want to draw the isosceles triangle and show its isosceles. It's always really important to do that. Your isosceles triangle doesn't have to look the same as mine, but that's what I usually use. It says it has legs of 14 and a base of 10. And the question says, find the measure of the vertex angle. So this one has a little bit more work. We're looking for this angle at the very top. So we need to be very cautious of what it's asking. First of all, in this case, you have to have a right triangle in order to use trig. So you have to draw the height. The height is needed so that you can create a right triangle with a base of 5 and a leg, or in this case, a hypotenuse of 14. If we find this angle measure, I will call it x, we are using the adjacent and the hypotenuse. So if we compare the adjacent and the hypotenuse, we're finding the cosine of x. And the adjacent is 5 and the hypotenuse is 14. Please remember, when we don't know the angle measure, you need to use the inverse function to find that closest angle measure. So in our calculator, we use the inverse cosine function, and it's 5 divided by 14, and we end up with, says 69.075. Please don't round too early. So we have this angle measure x being 69.075. I believe that's what it said. Let's go back. 075. Yes. And so we have that twice because we have two base angles that are the same. So when you multiply that by 2, you would get 2 of those angles total. Oh, excuse me, my marker's all messing up here. There we go. So times 2. And so we have 138 degrees total. When you take 180 for that large triangle and you subtract the 138, you are left with 41.849 degrees. So we take this, and then the answer that we got in our calculator, we subtracted from 180, and we got just about 42 degrees because it says round to the nearest degree. So that's the vertex. For exercise 4, and again, please, if I'm going too fast or if you find that you're not getting all the notes, somebody please come up and pause the video. For exercise 4, a lighthouse at Cape Hatteras, North Carolina is 200 feet above sea level, so I'm going to mark that in. If it spots a boat at an angle of depression, we haven't really talked about that much, but if you notice, an angle of depression creates parallel lines even if one is invisible, so you can use this as 28 degrees because those are alternate interior angles. It's shown in the diagram what is the horizontal distance from the base of the tower to the boat. And so when we go ahead and do our check again. I'm going to focus on this angle measure. This is the opposite. This is the adjacent. I'm using opposite and adjacent, which happens to be tangent. I do, in fact, know the angle measure. The angle measure is 28 because we focused on alternate interior angles. The opposite is 200. The adjacent is x. Since we have the angle measure, we cross multiply. Again, this one I start with the variable, and it's a little bit more work. When you cross multiply, you get x times tangent of 28 equals 200 times 1, and you divide by the tangent of 28. So in our calculator, we have a little bit different motions, different operations being used. So I'm going to take 200 and divide by the tangent of 28. And when you do that, you get 376.15. 376.15. And so that's approximately 376 feet. Please make sure that you're rounding to the correct unit. The last one on page 18, number 5, it talks about a blimp hovering over the ground at a height of 1,150 feet. An observer at point A sees the blimp at an angle of elevation of 24. While an observer at point B sees the blimp at an angle of elevation at 38 degrees. What is the distance between the two? So you're looking the distance from A to B. Please be observant. Recognize this is not an isosceles triangle. So in this particular case, the 1,150 is the opposite for both angles. This is the adjacent for the angle of 24. This is still the opposite for 38, and this is the adjacent for the second angle. I did it in 2 separate colors. I also named 2 separate letters. So for the A observer, the comparison is the opposite over the adjacent, which is tangent. The tangent of 24 degrees, the opposite is 1,150 over x. We have the angle measure, so you cross multiply. You get x times the tangent of 24 equals 1,150, and you have to divide. And so that that distance is approximately 2,583. Again, please don't round until you absolutely have to. For time's purposes, I'm just trying to finish this for you. The last one, again, you have the opposite over the hypotenuse, which again is tangent. Same exact process, only we have a different angle measure. Again, we put it over 1. X times the tangent of 38 equals 1,150, and you divide by that tangent, and you get approximately 1,472. So altogether, that distance is approximately 4,055 feet. Thank you so much for your attention. I'm so sorry that I missed you today. Have a wonderful weekend, and I'll see you on Monday. Do the homework, please, pages 19 and 20. And don't forget, you have the optional video to watch for Regents Review.